Recently, our client John met his banker to discuss plans for a clean energy building. What he found was a shared passion for building something more. Momentum for change. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John. Recently, our client Tommy met his banker to discuss continuing his father's restaurant legacy. In us, he found a partner that understood the importance of passing the torch. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Tommy.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thank you for joining us on Space Nuts. It's an astronomy podcast heard on multiple podcast platforms globally, which is just outside of Dubbo, where I live in central New South Wales. And my name's Andrew Dunkle, your host, and joining me as always from the Australian Astronomical Observatory is Fred Whitson. G'day, Fred.
Good day, Andrew.
You would drive through globally quite often, I reckon.
I do, yeah. In fact, I did last night. I drove through globally. Yes.
Yeah, you did a big trek home, didn't you?
I did. From Coonabarabran to Sydney, a very, very well-worn path. It was a nice drive last night, very little traffic, beautiful evening. Oh, and Andrew, I've got to tell you this. The absolute highlight of the trip, I had a passenger with me, my colleague Reg Wilson, who's our lighting consultant for Dark Skies. I said to him, there is the shadow of the Earth rising on the atmosphere. This is this beautiful pinkish glow you can see
Yes.
on the eastern side when the sun is setting.
I've taken a couple of photos of it recently. It's been so lovely.
It's lovely. That's right. It's called the Belt of Venus. But what I said to Reg was, the moon's going to be rising somewhere in a few minutes. Look out for it. And so we were kind of scanning. We're in a hilly area, so there wasn't much to see until we came round a corner, and there it was, the full moon sitting right in what we call the Belt of Venus, this beautiful blue to pink to blue again glow. That's the shadow of the Earth rising. So that was absolutely stunning.
It was.
And made me glad that I'm an astronomer.
Well, I'm not, but I saw it and I was, it is just a beautiful sight. And where I live, I've got quite a panoramic view across the eastern Macquarie Valley, which is lovely.
Yeah. Very good.
Today, Fred, we're going to talk about someone we've discussed before on the segment, astronaut Peggy Whitson, and we talked about her potentially breaking records in terms of space travel. Well, she's done it. And they've referred to her as a space ninja, although she's not wearing black. But anyway, we'll talk about her, and I love the names of these things. A supermassive black hole, which has been found in our galaxy, which means we're all going down the drain, perhaps. And we'll answer a question from John. He's the only John on planet Earth, so you should know who you are. But first, let's talk about Peggy Whitson. This is one amazing lady.
Absolutely, Andrew. Look, this is a story. You mentioned records, and she smashed them all. She is an astonishing astronaut, a NASA astronaut, just recently returned to Earth from a stint on the space station. So just to summarize what her records are, her recent sojourn on the space station gave her 288 days in space, which is quite a long time.
Yeah.
And that adds to her previous missions to make a total number of days off the planet of 665. And that is more than any other American.
That's almost 2 years in orbit.
Yeah, that's right. Yes, indeed it is, altogether. Yeah, it's a long time. Yeah. 2 years of her life she spent in orbit. So no other American has exceeded that. Just for the record, it's the cosmonaut who's had the longest time, 673 days, over 5 missions, in fact. Fyodor Yurkishkin is his name. I'm probably mispronouncing it, but something like that.
Yeah, but
673 days.
You know, Fred, Peggy was there by choice. Poor old Fyodor was stuck up there because something broke and he couldn't get home.
I think that's right. Yes, I think you're correct. Yeah, we need to check back that. But no, Peggy, 665 days. No other American has done that. And it also exceeds that of any other woman. So, including astronauts of every other nation, she's beaten them to it because she's got the longest days. So that's a start. Okay, she is the most experienced female spacewalker, which means she has spent more missions, what we call EVAs, extravehicular activity. You get outside the spacecraft and you wander around. Now, you're wandering around not on any kind of surface because the space station is in orbit. So a spacewalk is a misnomer. It is actually, you basically just become an orbiting satellite of the Earth. It must be a very, very salutary experience because you're in your spacesuit. The only thing between you and the hostile universe outside is the fabric or the fabrics, and they're very complex, that make up the material of the spacesuit. But you are basically an orbiting satellite. But so why is she a record breaker? She's done that 10 times.
Wow.
10 times she's been outside the space station and done stuff.
Let's not understate it. It is dangerous work.
It is, yeah, that's right.
Extremely dangerous out there.
Yeah. Yeah, that's right.
And actually, especially the part where, look, you're out there in this void, in this vacuum of space, in absolute silence, and all you can hear is Simon and Garfunkel. I mean, it's really tragic.
I'm sure she's probably a Simon and Garfunkel fan. I wouldn't be surprised. But it's, as you said, you highlight the danger. And a couple of times recently, we've had incidents where basically there's been water condensing in the helmet of astronauts.
Wow!
Because something's gone wrong with their, humidity system in the spacecraft, and that is extremely dangerous because the water, of course, doesn't pool. Essentially you're weightless. So what you get is droplets of water floating around inside your helmet, and you breathe in one of those, and you're in big trouble getting water in your lungs. So that's been highlighted a couple of times over the past probably 3 or 4 years. That has occurred, and they've got the astronaut back inside as quickly as possible because it's a dangerous situation. So you're quite right. It's not a spacewalk. Sorry, cakewalk is, I think, the
not a cakewalk.
Word I was looking for. It's a dangerous thing.
Yes.
So she's done that 10 times. I'm sure she's enjoyed them. Most of the time, it goes without a hitch. You wouldn't send astronauts out there if they were at high risk of harm. It's just once in a while you get something going wrong. She's done 10. Okay, she has also become, with this particular mission, the first woman to command the space station twice.
Wow. Because
she was the space station commander since November when she went up. So that's another record. How many have we got now? About 4 or 5 or something. Oh
yeah, she's racking them up.
And the one that I guess is closest to my heart because I'm no spring chicken. She's the world's oldest spacewoman. She is definitely a spring chicken. Is Peggy, because she is such a wonderful woman. Very, very lively, full of life, full of enthusiasm for what she does. Absolute icon for people of her generation. Fantastic. Oldest spacewoman, age 57. She turned 57 during her mission. So I take my hat off to Peggy and salute her and wish her well in her future endeavours.
She does deserve the title Space Ninja.
I think so. Yeah.
Yeah. Good for her. That's fantastic. And I think that women can hold her up as a glowing example of what women can do. For so long, they were shut out of these things. They were seen as inferior and incapable, and it's absolutely wrong.
Completely ridiculous, as we all know. But that's great stuff.
Very good. You're listening to Space Nuts. More to come on Space Nuts with Andrew Dunkle and, of course, Fred Watson.
Space Nuts.
Right, now, Fred, we're going to talk about something that's come up in discussions many times, and that is black holes. In fact, we spoke about black holes only a few episodes ago. But this is new. This is news. This has sort of hit the headlines this week. An enormous black hole, which is also named Andrew's bank account, about 100,000 times more massive than the Sun, has been found lurking in the Milky Way galaxy. This is a very interesting and somewhat amazing find.
I think lurking's the right word, Andrew, because we haven't known about this black hole till now. And it is an amazing find. And I'll tell you why in a minute. But let me just explain the circumstances of how this has been discovered and put in a bit of background. First of all, we live in a galaxy. We call it the Milky Way galaxy, this huge swirling disk of stars and gas and dust, something like 100,000 light years in diameter. And of course, a light year, as everybody knows, is 9.5 trillion kilometers. It's a long way. So 100,000 of them is even further. It beats the global world outside Dubbo into fits, I can tell you. So we are about halfway between the center and the edge. And when we look in towards the center of our galaxy, about 25,000 light years away, actually, we're looking towards the constellation Sagittarius. That's the direction in which the center of the galaxy is. It's actually where the Milky Way is at its brightest and thickest, and that's because there is this huge aggregation of stars near the center of the galaxy. Okay, so we've known for about the last maybe 20 years with increasing certainty that at the very center of our galaxy there is a black hole. And this one is indeed a supermassive black hole. Its mass has been measured by the motion of stars that are orbiting around it to be about 3.6 million times the mass of the sun. So we're measuring it in millions of solar masses. That's the sort of standard yardstick for these supermassive black holes. Now, we think pretty well all galaxies have a supermassive black hole at their center. And one of the great hot topics in astrophysics and cosmology these days is which came first, the black hole or the galaxy. And it's probably the case that they evolved together. But galaxies seem commonly to have a supermassive black hole, sometimes far more massive than the one at the center of ours. We know of black holes, supermassive black holes, more than a billion times the mass of the sun in the centers of galaxies. So these things we lump together, as you've probably gathered by now, under the heading of a supermassive black hole. Now, on the other side of the coin, we see black holes in galaxies which are not much more massive than the sun, maybe 10, 20, 50 times more massive than the sun, 100 times more massive than the sun. And we call those stellar mass black holes because they've got the mass of a massive star, roughly the mass of a star. And they probably have originated from stars that have exploded at the end of their lives. Stars much more massive than the sun explode at the end of their lives, create a black hole, and you get something that might be maybe weighs 20 times the mass of the sun. But here's the puzzle, Andrew. There's nothing in between them. Yes. You've got these things that are, the mass of a star, things that are nearly the mass of a galaxy, and nothing in between.
Yes,
and that
we've had a chat about that before. There's no medium-sized black holes. In basic terms. That's
right. We've got a fancy name for them. We call them intermediate mass black holes because they are intermediate between the big ones and the small ones. Look, there's no holding we astronomers when it comes to fancy names for things. Intermediate mass black holes. So what's the great outcome of this story? Well, we found one.
Yeah.
And that's why it's exciting. So what's happened is a group of scientists, actually Japanese scientists, although they've been using a European telescope, which we've talked about a number of times recently. It's a radio telescope called ALMA. ALMA, of course, is an acronym for the Atacama Large Millimeter Array. It's operated by the European Southern Observatory and a few other institutions as well. In northern Chile, it's actually in the northern Atacama Desert. I've been there. The telescope's at a height of about 5 kilometers, so you can hardly breathe when you're near it.
Sounds amazing.
It is pretty amazing. So it's an array of telescopes, radio telescopes, that look in what we call the millimeter region of the spectrum. And that's a great way of probing gas clouds in space. So what the Japanese astronomers have done, led by an astronomer at the Keio University in Tokyo, they've been probing gas clouds not too far from the galactic center, maybe 200 light years from this supermassive black hole at the middle of our galaxy. And they found this cloud of gas, and it's gases that to us are completely toxic. There's sort of hydrogen cyanide and all kinds of stuff in there. There's quite an agenda. Carbon monoxide.
You're talking
many
about
of
my
these.
wife's cooking now, aren't you? Carry on.
I'm not going there, Andrew. I'm definitely not going there. So this cloud of gas, and what they've found is that there are sort of churning motions in these gases that can only be caused by something very, very compact and very, very massive at the center of the gas cloud. What is it? Well, it's so compact and so massive that it can only be a black hole. And the key thing is that it's about 100,000 times more massive than the sun. Now, that sounds like a lot, but it's much less than a supermassive black hole. And that qualifies it as one of these elusive intermediate mass black holes. So this is an indirect observation. Black holes, you always observe them indirectly. Principally, you observe them by looking at the motions of things around them. And in this case, you're looking at the motion of gas around the black hole. So they've published a paper in Nature Astronomy, the prestigious, probably one of the most prestigious journals in the world. They speculate that this newly found black hole could actually be the black hole that used to be at the center of a dwarf galaxy that was basically subsumed into our own galaxy, because that's what big galaxies do. They gobble up smaller ones. Yeah. And actually, we think that's how black holes become supermassive, because they gobble up smaller galaxies with their own black holes, and that adds to the black hole at the center of the galaxy. So this looks like a very, very nice piece of work that, as I said, probably answers one of the big questions that astronomers have been asking for many years. Where are the intermediate mass black holes? Here's one that we found.
But does it, Fred? Because in all the years that you and I have spoken, there's one thing that sticks in my mind. We have found one. And that doesn't prove that there are others, but if we find another, then the dominoes start to tumble. It's the same as the life in the universe question. We only know of one planet with life.
Exactly. So you're right. That's right. It's a unique, a single example, but you can bet your life there'll be more turning up in due course as astronomy technology improves and we find, more interesting bits of the universe to look at. So a great story, and I'm very encouraged by this. I think it's something.
And it's not often that you and I talk about something that is missing in the universe, and then a few weeks later it's found. I mean, that's right. Pretty rare too. It
could be a real turning point. Of course, it's probably maybe these astronomers listen to our podcast. That could be what it is.
Next week, Life on Europa. Well, who knows? But yeah, that's interesting. So there'll be probably more to come on that, and they'll certainly, now that they know how, they'll probably be able to find a few more. Fred Watson is astronomer from the Australian Astronomical Observatory, the expert on this podcast. I'm Andrew Dunkle, your host, and you're listening to Space Nuts.
3, 2, 1.
Space Nuts.
Finally, Fred, a listener question, and we love listener questions, and you can certainly send them to us on Facebook or Twitter. We welcome them all, and we answer none, if we can help it. But we're going to answer this one from John Milton in Sydney. Now, John has said, loved your article on Titan. When the sun becomes a red giant, will Titan be the new habitable zone? I guess we won't be around, but might the solar system get a second chance at life, aka Earth's early evolution? Interesting question, John. Very interesting. So where will the Goldilocks zone be when the sun turns into a red giant, Fred?
Andrew, John's right on the money. What's going to happen as the sun evolves into the later phases of its life? And we're now talking about maybe 3.5, 4 billion years down the track. Well, put it in your diary if you want, but you might have a long wait. As the sun, what will happen is its atmosphere basically starts puffing away from the nucleus of the sun, and that raises the temperature. The sun's habitable zone will begin to move out. We sometimes call it the Goldilocks zone because it's that region of space where it's not too hot and it's not too cold, but it's just right for liquid water to exist. So it's all about the possibility of liquid water. And of course, at the moment, the Earth sits firmly in the sun's Goldilocks zone. So the sun evolves into a different kind of star. The Goldilocks zone indeed moves outwards. So it will move past the orbit of Mars. Mars's copious quantities of water will thaw out, and might even become a water world. It might even be covered with water because there's so much ice there on Mars. The moons of Jupiter, the ice moons of Jupiter, likewise will become water moons, and eventually Titan itself will be in the habitable zone. Now, Titan is often held up as a model for what the early Earth was like, with kind of primitive weather systems and a whole meteorology, which on Titan now it exists, but it's different from the Earth, because on the Earth our meteorology is all driven by water vapor because of the place where we are in the solar system.
Yep.
Titan, though, its weather is driven by, as you know, we've discussed it many times before, liquid natural gas. It's hydrocarbons. It's actually methane and ethane, of which there is enough in the atmosphere that occasionally you get rain and it forms rivers, and we know that there are what seem to be fairly permanent lakes and seas on Titan, but they're liquid hydrocarbon rather than water. So that, of course, as what we might call the conventional habitable zone, where you're looking at liquid water, as that reaches Titan, all those things are going to disappear. They'll evaporate. They'll turn into gas. And of course, the surface of Titan, which is made of solid ice, that will turn into water as well. So it will become a very different world. It will actually be covered in liquid water. Maybe life could evolve there. John's suggestion that maybe the solar system might get a second chance at life, that is a very good one. And indeed, it might have already happened by then, because the same kind of thing could have happened on Europa, Ganymede, Callisto, the moons of Jupiter, which we know are pretty icy, solid ice. But I think there's a different way of looking at this, because if you imagine microbes, and certainly life scientists have postulated this, which can exist at minus 180 degrees Celsius, which is the average temperature on Titan, and can thrive on methane and ethane. They breathe hydrogen. They eat acetylene. They don't exist, but they've been postulated. Or they might not exist. They may actually exist. If they do exist, then Titan is already in the sun's habitable zone for hydrocarbon-based life. And that is the exciting thing about this, because Cassini has uncovered so much detail on Titan. We're sort of mourning Cassini at the moment because it's on its last legs. It's within a few days of the time we're speaking, it will plunge into Saturn's atmosphere, and that will be the end of the project. But it may have already uncovered an area where you could have a habitable zone based on methane and ethane. And surely there will be missions going back to have a look and see what's there.
Fascinating. Now, John's question and your answer has prompted another question in my mind.
Right.
That's the journalist in me. What would a red giant's effect be on other outer planets? If it's going to turn Titan into a liquid planet and burn off the gases and things like that, what effects are it going to have on the gas giants,
on the gas giants themselves,
and the outer satellites?
Yeah, you're absolutely right. The gas giants, they'll be heated up. They'll probably become very, very puffy. We see puffy gas giants when we look at exoplanets. We know that there are some that have got really quite loose atmospheres, and that will probably happen to Saturn, Jupiter, Uranus, and Neptune. And their moons will, of course, thaw out. The same will happen with all these dwarf planets and Kuiper Belt objects way out beyond the orbit of Neptune. There's a place called Pluto, which you may have heard of, which will also melt eventually, because Pluto is largely made of ice too. May even have an ocean underneath, even at the minus 228 or whatever it is degrees Celsius that Pluto's surface is at. Remarkable stuff. It's interesting to think about what will happen to our solar system. And it tells you that really, when you look out into space at other solar systems, you should expect to find anything, because you're looking at stars which are in different phases of their evolution. And indeed, that's exactly what we do find, a whole plethora of different kinds of solar systems. That's why it's so exciting.
And just very quickly, another question. Would a puffy gas giant have a negative effect on a moon like Titan?
Yes, probably.
So they may not be able to.
No, I mean, look, Titan's going to be. if Titan is very wet and your planet is puffy, who knows what might happen?
Yeah.
You could have all kinds of different kinds of life forms evolving. And of course, we are talking about very long timescales here. These processes
there might
slowly.
be a window in between the effects.
Yes, yes, that's right.
Fascinating. All right. Thank you for your question, John, and keep them coming. As I said, you can send us your questions through our Facebook and Twitter accounts. Just do a search for Space Nuts and look for Fred's face. Fred, thank you as always.
It's a great pleasure, Andrew. I do send in your questions. It's great to be able to answer them, and the ones that we can anyway.
Yeah, we've got a really good one, but we've got to do a lot of homework on it about being pregnant and giving birth in space and what the effect on the baby would be. We love the question. We just don't know the answer yet.
Not yet.
We're going to figure it out. We're going to figure it out. Fred, we'll catch you next time. Thank you.
Sounds great, Andrew. Good luck with the wider universe there out in Dubbo.
Yes, the galaxy outside of our town. We actually do have that. I forgot. I should mention that because of our proximity to your telescope, all the towns leading up to the Siding Spring Observatory have planets in them that are measured to be on a scale equal to the solar system. So Dubbo is Pluto, where I am, and as you get closer to Siding Spring, the planets are popping up on the highway. It's very clever. I love it. Should have mentioned that.
Yeah, we might talk about that sometimes because I had a lot to do with that.
Yes, you did. I remember doing the interview when it first came up.
Yeah.
All right, see you, Fred. We'll catch you next time. That's Fred Watson from the Australian Astronomical Observatory, and from me, Andrew Dunkley. Thanks for listening. We love hearing back from you, as I said. And if you want to tell your friends about us, we love that too. You can pick us up on Audio Boom, Apple Podcasts, Podbean, Stitcher, etc. I think that's a podcast platform too. Keep following us on Facebook and Twitter and everywhere else. And we'll catch you next time on Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast. Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.